Hello, welcome. I am back again, just from an hour ago. We are back here though. It does not stop here at near DevHub, and we have tons of great stuff going on in the near protocol with everything. And we have an awesome workshop this afternoon for you that we're going to do some more building on BTC. If I could say one thing about the proximity team lately is that they love building on BTC. There's so much content coming out about this, and so we want to actually make sure that we are capturing all of that for you. So we have Greg and Edson coming from proximity to talk all about that and do a workshop with everybody. I don't want to hold anyone back. I don't want to waste anyone else's time. The links are down below if you want to get started with anything else. But otherwise, let's jump right into the workshop. Let's bring up Greg and Edison to the show. Hey, guys.
Hi, guys.
Hey, hello. So why don't you guys talk a little bit about what we're going to workshop today?
Yeah, sure. Yeah, I was going to go through the near multi-chain example that we have and just all of the Bitcoin parts. Just give like a short demo and then walk through the code a little bit.
Yeah, that sounds awesome. Feel free to share your screen whenever.
Okay.
Edson, how are you?
Hi. Yeah, I'm very good, thank you. Yeah, after Greg do his presentation, I'm gonna also walk through an example. We did something called the OmniBox, which is a small development framework to create chain abstracted applications, and we're gonna show an easy way to develop BTC apps with Near.
Awesome. Looking forward to that. Cool. I won't hold you guys back. Greg, whenever you're ready to show your screen, feel free to bring it up and we can jump into it.
Sure. Sounds good. Okay, here we go.
All right, let's bring it up to the stage. There you go. We'll have the banner here.
So yeah, this is the near multi-chain demo example. I'm running it locally. And so, yeah, when you first boot this up, it's going to be on Ethereum. And so if you switch over to Bitcoin, this is your path. This is the derived address. And then this is the to address. And so I'm just going to send like a small amount of Satoshis to my own address. And so the way this works is you sign a near transaction that requests a signature from the MPC service. And so I'll request that and approve this transaction. Yeah, so this is the testnet signer. Okay. And then I'm going to go back to Bitcoin. And then, so we have a signature here. And so what the app did was it took that signature and it created a signed transaction, which is a little different than like most Bitcoin wallets. You have a private key that does it signing all locally, but we don't have a private key, and so we have to request that signature from the MPC. And so then after you have that completed transaction, you can broadcast that to the Bitcoin network. And so that all that does is send the signed transaction to Blockstream, and then that gets included on chain. So here's the transaction, yeah. So yeah, it works. This is a successful Bitcoin transaction. And yeah, let me just go through.
Before you just jump into the code, I want to just level set for people a little bit here. What's happening? So on this process, while you are generating a transaction to send to the Bitcoin network here, now this is obviously happening pretty quickly, but you are still beholden to the block timing of Bitcoin, though. Still correct?
Yeah, correct. So yeah, so this isn't like kind confirmed yet. It's still waiting for all of the like confirmations.
Mhm.
But it's in mempool and it's like on its way to being included.
Right.
But yeah, it'll take a few more minutes to be confirmed.
Right. So something that people should need to consider is that even though you are simplifying this process, you're doing it, the transactions being generated quickly, being signed quickly, but you still have to wait the normal time for, the Bitcoin to actually transaction to actually be verified and then fully on chain.
Yeah, exactly.
Right. Cool.
So yeah, I guess I'll walk through some of the code, just starting with everything that I just did on the app. So there's just the like your React component that just does all of this. But the main thing here is when you click the button, you're going to call this request signature to MPC. I can increase this a little bit if it's easier to see. And then that's going to call this Bitcoin service. So yeah, so request signature, it just takes your wallet, the path, the partially signed Bitcoin transaction. I'm going to, let me show you that next. So there's this method construct PSBT. PSBT is a partially signed Bitcoin transaction. That's the object that we had to use to create these transactions. Because like I said earlier, typically Bitcoin wallets have access to a private key. And so you can just create the signature locally and then construct your transaction like the normal way. Our method, like you have to break that down into like separate steps because we don't have access to the private key. And so what we do is we construct this partially signed Bitcoin transaction that has like all of the information that it needs. It just doesn't have the signature. And so this is where it checks like what type of Bitcoin transaction it is. If it's like a legacy pay to public key hash, it needs to be formatted a certain way. The one that the example is using is SegWit. And so this just constructs a transaction. It includes like the output, which is where I'm sending it to. And then the input, which is the UTXO that I'm using to send. And so when we go back up to the request signature to the MPC, it takes in that PSBT up here, and then it does this it does this dry run. And so it this like code right here is it is going through the PSBT, and it is getting all the information that it needs to request the signature. And so once it has that, then we send the near transaction to the MPC. Hold on. Yeah, and then once we have the signature back, yeah, we can call the real run. So there's this difference between like the dry run and then after you go through your My Near wallet, you make that near transaction, you get that signature back. Once you have the signature, you can go through and do the like real run.
Is the dry run just simply to like better validate the transaction, or is there another purpose there for doing that?
Well, so the library that we're using, Bitcoin.js lib, we need to do it this way because we need like a very specific like transaction hash. We need like a hashed version of that PSBT because that's what the MPC needs. And so that's why we have to do it this way. So it's it's sort of a hack actually. But Bitcoin JS lib is just not like, it's not set up to do these like multi-step Bitcoin transactions. And so you have to like pretend that you're doing, you have to pretend that you're constructing a Bitcoin transaction, like the normal way. And then, but yeah, basically we just do the dry run to get that transaction hash. And then we use that to send to the MPC. And then we get the signature back. And then once we have the signature, we can complete the PSBT. And then we just call sign inputs async. I'm trying to find where that is. Yeah. So yeah, sign input async, and then PSBT finalize all outputs, and then you can return the thing. And then down here, you broadcast the transaction, which, so once you have the signed transaction, it's just a normal API call, normal post call to Blockstream. And then that just sends you back like your successful hash or error if something went wrong. And then it just gets printed to the screen. Yeah, so it's kind of complex. Yeah, the main complicated thing is that like dry run and then like completed run, that you have to do that in 2 steps. That took us a while to figure out, but yeah, this is how it works.
Yeah, that's nice. And so now this is all like through the service. The developer doesn't actually have to worry about that. It's just good to know what's happening there, but like they don't have to now worry about that. You've already built it into that service.
Yeah, exactly. Yeah, hopefully nobody else should have to figure that out.
Figure it out. Nice.
So yeah, that's this demo. I can hand it off to Edson now.
Yeah, real quick before you hand out, this was good to see the code behind some of this. What are some things though that you think developers can start to do with this? So like the demo obviously is very straightforward, just like, hey, this is how you sign a signature. This is how you sign a transaction. But what are some things that you guys see developers actually leveraging this for?
Yeah, sure. So yeah, I mean, this is just an example of how you can send Bitcoin using a near address, basically, with chain signatures. And so any application that you have that you want to send Bitcoin, but through near and through chain signatures, this would be a good reference to just see how you do that. But yeah, I mean, there's a ton of applications. I mean, I could see this being used for something with like runes or ordinals. I mean, yeah, I mean, even like a lending or borrowing. Yeah, I mean, pretty much just like if you want to like do anything with smart contract capability with Bitcoin, this is a pretty good way to do that.
Yeah, I mean that's a really interesting. So you're basically enabling smart contract behavior, on Bitcoin.
Yeah, exactly.
Yeah.
Yeah, I think a good analogy for this particular case is that a smart contract on Near basically can take control of an address on the BTC side. So you can have any logic that you can imagine on Near, taking advantage of the low transaction fees, scalability, and so on. But then you can reflect all those changes on the BTC side in any of the forms where you can use runes, you can do anything that you can imagine thanks to having a smart contract on Near controlling that particular address.
Neat. Okay. I like that.
Okay, I guess it's my turn.
Yeah, let's go for it.
Okay.
Oh, there you are. Nice. Evan.
Okay, share the screen. Window. Can you guys see my screen?
We can now, yeah.
Okay, so Greg's presentation was more focused in the front end part, and now I'm gonna present more from the smart contract side. And we've been trying to create examples for creating a smart contracts with the chain signatures technology. And along the way, we found that it's quite complex in general to do chain abstracted applications. And we created something called the OmniBox, which is like an opinionated testing environment for this type of smart contracts or chain abstracted applications. And what we essentially did is to put together a lot of utilities and functions that we saw are very common. And we set up testing accounts and so on. So if you're a smart contract developer coming from the EVM world, you have in that side frameworks like Foundry, where you have a blockchain demo, a blockchain that you can run locally and so on. And in the BTC world, there are also tools to do something similar. And also on Near, you have workspaces where you can do that. But you see, there are many frameworks. And when you are trying to develop this chain abstracted application, it can get a bit complex. So we say, okay, let's integrate everything with OmniBox. It's going to be an opinionated testing environment, but we believe this is going to make your life super easy as a smart contract developer doing chain abstracted contracts. So there are some of the features like I said, we are putting together. Yeah, when you run the OmniBox, you basically have available test blockchain for Bitcoin, a test blockchain for EVM chains, and also the near workspaces available. Another aspect that we do, we have, like I mentioned, pre-configured accounts. We have the capability also, okay, these accounts are not enough for you. You can create more accounts. And we also have utilities to compile it and deploy this smart contract that you are developing. Now, this compile and deploy to testnet is because right now, the MPC signer or network is only available on testnet. So it was very common for you as developer to, okay, I do the new contract, but then I need to deploy that contract and interact with the MPC signer on the testnet. And we just make things way simpler. And also we added utilities for account derivation, signature construction, and so on. So yeah, we cannot say this is opinionated way, because I mean, doing a framework like this from scratch and adding all these capabilities to configure and so on, it can get very complex, especially because we are interacting with different chains. So we say, okay, let's propose this OmniBox way, and this is how the workflow is going to be. We think it's a very simple flow, and that's why we are proposing this flow. So the typical workflow for a developer will be, okay, I'm doing a smart contract, integrating the MPC signer, and possibly I'm using the Omni transaction RS library that is going to help me to do transactions for Bitcoin, for EVM chains, and also for Near. Okay, then you deploy it to a testnet, and then you want to interact with this contract, let's say performing by executing a transaction, which means you are calling the MPC signer. Then you get the signed transaction and you propagate this to the destination chain. Why this is important? This is important. The propagation part is super important because you can be signing wherever you want, but at the end of the day, you only are going to be sure that this particular signed transaction that you got is valid when you can propagate that in the destination chain. So a very simple example, let's say I'm doing a Near contract that is trying to create an NFT on a particular EVM chain. Then I do the Near contract, that is creating this transaction is signing it, and then the person that is calling gets a raw payload that is fully signed. And that payload was signed by the MPC signer, but then you can propagate this to the destination chain. And that's it. So in order to give more clarity how this looks like, there are some examples here in the OmniRS repository. We have a lot of examples for complex cases. For instance, for with transactions with multiple UTXOs. Here we have calling from ROS clients. Here we have examples propagating to a testnet. And here, this example is basically, yes, you are signing a legacy transaction, but you are propagating into your local Bitcoin node that the OmniBox is spinning up for you. So first, the smart contract. Here we have the logic of a smart contract where basically here you are creating what is called, so right now we are speaking about a BTC transaction, okay? So in the BTC world, you have this SIG hash that has to be signed, and then you basically form a transaction using the signature. So first, okay, we create a SIG hash. This SIG hash is created by using the Omni library here. You pass a Bitcoin transaction that is serialized. You pass extra required parameters, in this case, the Bitcoin pop key. So you can do everything in one single transaction. And here, okay, I created I encoded, I create the SIG hash, and then I call the MPC signer. So when I call the MPC signer, I'm basically creating a promise. I'm probably, yeah, I don't know if it's very small. Can you guys see properly?
Yeah, I can see you good. Yep.
Yeah, so here basically we are calling the MPC contract. And then because we are using a promise, we are calling the callback. This callback is receiving the original transaction payload that we are passing, plus the Bitcoin pop key that we require so we can do everything in one single transaction. And here, once we receive the signature, we put everything together and we return to the client. So basically, as a smart contract developer, I create this contract, I do one transaction that is calling this function, and what I get as an outcome from this contract is a payload that I can propagate to to the Bitcoin node that is running locally or in testnet. It depends, but here in this example is locally, okay? So from here, I want you to picture there is a smart contract on Near that is gonna be deployed to testnet that is interacting with the MPC signer and that I'm creating locally, okay? I'm developing. So, okay, here's my contract, here is my function, integrate MPC signer, I get the payload, boom, done, okay? Now, let's see how we propose to develop this. And this is mostly following a test-driven development environment. Test-driven development approach, where, okay, let's do this contract, but since the beginning, let's do an integration test. And this test is deploying to testnet, is interacting with the real MPC signer, and then I need to propagate this to a destination chain, either testnet, either locally. It can be mainnet too. That's up to you if you want to spend that money. But for now, in this example, is locally, okay? So as I said, the OmniBox will help us. And then we simply say, okay, OmniBox, new start, okay? So here the OmniBox has already started. It started new workspaces, Anvil, that is the EVM chain that is running locally. And Bitcoin core node in reg test mode. So we have Bitcoin, EVM, everything there available. We can override the options if we want to. So let's say I just want the EVM functionality and NEAR functionality. Yeah, that's possible. But by default, you have everything ready. Then we call something context. So everything about BTC is available in the BTC context property. And as I mentioned, we have pre-configured accounts. Most of them, all of them exist in the different contexts. So here I have both already created. It's a legacy address, and I simply create a variable referring to that. Then I can derive the address of the contract that I'm creating. Because remember, this contract is going to be deployed to testnet, and this contract is interacting with the MPC signer. So the contract with the MPC signer will basically have an address that this contract is controlling. Okay, so this derived address is the address that the NEAR contract will control. And then we get this script pop key. That's something mostly from the BTC world that is useful once the transaction is completed. But then we need UTXOs. So if you are developing BTC applications, you need to have UTXOs. And this is also a reason why we like this approach, because the testnets in the BTC world are very difficult. The faucets, sorry, are very difficult to really get the UTXO. Some of them doesn't work. I mean, the experiences definitely can be improved. But when you have the OmniBox that internally is using a BTC node in a reg test mode, you essentially have the power to give UTXOs to any address. So here we are giving UTXOs to the address that the smart contract that I'm developing is controlling. So I'm saying, okay, this is my contract. This is the derived address that the contract the derived address is in the BTC world. This is the address in the BTC side that my contract is controlling. Now I'm going to give UTXOs to that address in the BTC world. And then we simply get the UTXOs. Here there are some gotchas about them. Yeah, we basically need to give, again, UTXO just for confirmation aspects that the Bitcoin core node in reg test mode requires. But basically what is happening here is, okay, OmniBox is starting everything. I get a BTC address controlled by this NEAR contract that I'm developing, and I'm giving UTXOs to that address that I'm controlling, that the contract is controlling. So now the contract, so it's okay, I'm giving UTXOs, now spend that. And here is where we basically create a transaction. This is a normal BTC thing. You have the input, you have the output, and then you create the real transaction where you pass the outputs. Here you have two outputs. One is to the person who is going to spend it, and then might change. And I still remember, I mean, if you are new to the BTC world, the UTXOs are like bills. So imagine I have a bill of $5, and thanks, Greg, for this great analogy. I have a bill, let's say $5. I give you the $5 bill, but probably I'm not paying you $5. I'm paying you $1. So here is the spending. Okay, I spend $1 and give me 4. So that's why you need the input is, here is my bill of $5. You are spending 1, but give me 4 back. So that's why there are two outputs. Okay, but here we are creating the Bitcoin transaction again using the Omni transaction library, and And then we are simply sending this transaction to the smart contract. Remember that the smart contract has this create SIG hash and sign P2PKH, which is this one. Okay. So this, oh, and by the way, the OmniBox is automatically recognizing that you have a smart contract in source live.rs. So your smart contract is automatically compiled. We are recognizing if you have done any changes. And in case there are some changes, we deploy a new version on testnet. In case no, we simply don't deploy. So you save some testnet funds. But here we are simply calling to that contract that you are developing that is now in testnet. But as you see, the abstraction that we did is super simple. The OmniBox is giving you also this friendly near JSON RPC client, where you simply say, okay, OmniBox friendly near JSON RPC client, send action, and bam, you just call this function, pass the arguments, that's it. Here I get the transaction ready, and then I propagate to Bitcoin network. That, by the way, the BTC context in the OmniBox is giving you also. So you have BTC context, client, call, and you send the outcome that is coming from the new contract.
Yeah. Quick question about this. So from like a design pattern standpoint here, one thing that sounds like it's different, and correct me if I'm wrong here, is one is that like this test suite really is about what's testing that is actually deployed versus just testing locally during like, like after compile or something like that, right? We're saying we want to actually test what's being deployed.
Yeah, I think you could see this more like an end-to-end. Probably I call it integration test, but it's really I'm deploying the contract, I'm executing a transaction, I'm getting the outcome. This transaction that I'm executing is interacting with, it's in the testnet, it's interacting with the real MPC signer, it's giving me something, and I'm propagating that to either real network, like a Bitcoin core node in rectest mode, or it can also be a testnet. But you are essentially testing the full flow, and that is a different level of testing because you can have your unit test directly here,
right,
within the contract. So I guess I call it integration test, but you could even say that it is an end-to-end test. Or I don't know if the end-to-end test involves I think it's an integration test because the end-to-end might involve also the front end.
The front end, yeah.
Yeah.
So I want to ask another question here with this. So this is two different approaches here, right? So like one, so what Greg was showing is obviously front end based, and it's focusing on creating and setting the signature. This is a little bit more integrated. This is at the smart contract level. From your recommendation, let's say you personally, like I guess from proximity standpoint, is the when you're thinking about like software design, is the focus here to be more at the smart contract level, and is that where you feel the greater benefits coming from? Is that why you developed OmniBox to better support that, or is it really kind of leaving it up to the end developer of like what makes the most sense?
Yeah, that's a good question, and I guess it will. I guess the best answer is it depends, no?
Sure.
And I guess different developers might have different approaches. I personally like to have proper integration tests, and always segregating the different layers. You have the smart contract layer, and if you are coming from the Web2 world, you can see that that's an API, right? This is an API. This is living in the back end. it has internal functionality, it has utilities, it has, and so on. So what is exposing to the world, and I guess that API or function are can be isolated from what could be the front end. And I think, in my opinion, it will be more difficult to do the full thing manually. Probably at some point it might be faster, but as you continue growing and your project gets more complicated, you're gonna get into problems because you are gonna need the faucets, you're gonna need a lot of things. And with this approach, you can isolate. Okay, I'm doing a smart contract. This is what it enters. This is what it comes out. So you have very clear your box. This is what it comes in, out. All these things are tested. I am having an integration test. I know for a fact this thing will run. I can set up this suite of tests in my pipeline, in my repository, and I'm gonna sleep. Okay, if someone is calling at midnight, there is a bug or something, I know for a fact that it's not gonna be mine. But I don't know. For me, it gives me peace of mind. It gives me peace of mind. So as a developer, I always try to advocate this thing, like, okay, and I think this is a very cheap way of having peace of mind, because it can get very, very complicated. But I think this is a very cheap way. I mean, you don't even need to do unit tests and have all these layer of tests. But in 120 lines, you can really be sure that your near smart contract is bulletproof, and then you can simply integrate the front end and interact with it. But you are gonna avoid a lot of manual testing. Like, let's say you want to do a transaction, and you will need a lot of funds for the faucet in near, but also on BTC. So I think it can get more complicated. And but if you isolate and focus in one side first, then the other, you wouldn't need to do the full thing all the time.
Yeah, I do also appreciate where there are options, right? So as a developer, a little bit, right, if you feel more comfortable doing a particular way, here are some best practices, but there are options to go, which I think is always an important piece for anyone building, is you don't want to you want to feel comfortable with what you're shipping.
Yeah, no, exactly. I think, it all depends on the developer, how you feel comfortable. That's why we were very, very direct and honest. This is an opinionated testing environment.
Yeah.
This is the OmniBox way. This is what we propose. We are not, obviously, we are open for feedback, no? And I mean, if the community can give us feedback, that would be super good. The more, the better. But we also didn't want to tackle all the parts because it's going to be super complex. But we were, okay, let's start small. I think this is an opinionated way. Let's be transparent. What is our intention? And from this point, we will see. For us, the benefit is that, I'm not going to lie, but this test at some point was 400 lines of code. And now it's just 100 lines. So for us, that was a huge impact. And it is very simple now. Well, more simpler. That's why we get all these utilities, and we expect, okay, let's start like this. We hope developers see the value, and we can iterate and be open and flexible too. Why not?
Yeah, no, I love it. This is great, and I think it will be definitely helpful to developers looking to build on this for sure. Good stuff. Yeah, no, this is awesome. As we wrap this up here a little bit, any last kind of things that people should know in getting started building with this, especially whether it's either part of it or just in general? What do you think?
Greg, do you want to add something?
Yeah, sure. I would just encourage people to download the example, play around with it, and see if they can tweak that into something that suits their needs. Yeah, I will say that just piggybacking off of Edson's presentation, it is significantly harder to build tests in the front end, and so if that's important to you, then doing it through the back end, like smart contract approach, might make more sense. But yeah, there's a lot of benefits to doing it all on the front end too.
Yeah,
it just kind of depends on your use case and the developer.
definitely. Well, great. Any last words, Edson? That was a great presentation there.
Yeah, get started building BTC on there.
Yeah, perfect. Yeah, awesome. If anyone has any questions or they get stuck with any of this stuff, what's the best way to reach out? The Chain Abstraction Telegram group, is that probably the best?
Yeah, I would say so. I usually see all of the messages in there. If there's a question about the example or anything technical, I can usually respond to those there.
Awesome. Perfect. Well, thank you so much, guys, for coming on and doing this workshop. And I hope everybody learned a little something today.
Thank you.
All right,
Thanks,
guys. Thanks. Great stuff. I hope this was a fun workshop for everybody. We have, again, tomorrow, we have our kickoff for the 1 trillion agent hackathon. That's coming down the pipe tomorrow. And then we have next week again on DevHub Live on Thursday, 4 p.m. UTC, Nightly Wallet. So until tomorrow and until then, give this stuff a try. Hope you guys are building, and we will talk to you soon. Thanks, everyone. Bye-bye.